let's review multiplication formulas related to binomials. So a plus b squared, a squared minus b squared, or a minus b squared. The first problem is going to be to simplify this expression. So a to the power 6 minus b to the power 6, and then divided by this one and this one. So I want to do the divisions in the given order. So let's divide a to the power 6 by a to the power 6. So we know that this is a cubed square minus this one, b cubed square. So this number is a cubed square minus b cubed square. So we can rewrite this as a cube minus b cube, difference of squares, a cube plus b cube. So if you divide this by a cube minus b cube and a cube minus b cube, what you will get is definitely these are cancelled out, a cube plus b cube, right? So which means this part of the expression is a cube plus b cube. So that's equal to a cube plus b cube divided by a square minus ab plus b square. Now recall the formula for sum of cubes. What was a cube plus b cube? That was like a plus b, a square minus ab plus b square. If you divide this by a minus ab plus b square, in the end, so like this number divides by this one, that's result is a plus b. So if you simplify this expression, you get a plus b. Next, we have a classic type of problem where we are given x plus 1 over x is equal to some number, and we want to find the powers of that. So for example, with this one, if I want to find x squared plus 1 over x squared, I need to take the square of this expression from both sides. Let's see what happens. The square is equal to 3 squared, so that's 9. And if you open this here, that's x squared, a plus b squared formula. So basically 2 times x multiplied by 1 over x plus 1 over x squared is going to be equal to 9. Now pay attention to this part. In this part, x times 1 over x is just 1, so we have 2. That means we will be having this x, and so x squared plus 1 over x squared will be 9 minus 2, or 7. We are subtracting 2 from both sides. So value of this expression is 7. X squared plus 1 over x squared is 7. How about the x cubed plus 1 over x cubed? How do we find x cubed? How do we find x cubed plus 1 over x cubed? So one way is to take the cube of this expression from both sides, as we did for the square. So you can do that. So that's one way. But another way is the following. So just take this expression from the part A and multiply this by this equation. So multiply it by x plus 1 over x on the left and by 3 on the right. So what we have, when you open the parentheses here, you'll get some terms with x cubes, but on the right we have 21. So if you open the here, that's x cubed plus 1 over x plus this one is just x and plus 1 over x cubed is equal to 21. Now we know that this is 3. That means x cubed plus 1 over x cubed is 21 minus 3. So that's 18. This problem is not a difficult problem. There are different ways of solving this problem, but just in order to give you some idea. So this may not be the best solution, but in order to give you some idea, I'm going to show you the following solution. So that's going to be, so if you multiply this equation by 2, so let's write it like this, 2 and 2a squared plus 2b squared, maybe. So you can rewrite the given expression in this form where you have 1 over 2 and each of these terms twice, bc, and a squared is twice, b squared is twice, but written in separate places. Now what you can see is that that's 1 over 2. The first one is a minus b squared plus b minus c squared plus c minus a squared. As you can see, we know the values of these expressions. So a minus b is 2, b minus c is 4. Adding these two expressions, add this one to this one, you'll get that a minus c is 6. So you can put this to be equal to 6. Now just plugging the numbers, we have 1 over 2 is 2 square plus 4 square plus 6 square. Or that's just 1 over 2. That's 28. The fact that you can rewrite this expression in this form can be very useful in some problems, because this is some expression of squares, and so this is some quadratic expression, but here it turns out it is sum of squares of some numbers. And finally, we have the following problem, which was also in the previous problem. We are going to do this one more time. So what I'm going to do here is, let me evaluate this part. So this part is 3 times 5, which is 15, right? And we know that 15 is 16 minus 1, or it's 2 to the power 4 minus 1. So let me replace this part by 2 to the power 4 minus 1, and the rest is same. So if you multiply these two terms, only first two, you'll get 2 to the power 8 minus 1. So by replacing it by 2 to the power 8 minus 1, we will get the following expression. Now you can repeat that a couple more times. So this is going to be 2 to the power 16 minus 1. And this 2 to the power 16 minus 1 and 2 to the power 16 plus 1 will be 2 to the power 32 minus 1. Subtract 2 to the power 32. And this difference is going to be negative 1. So if you multiply all these numbers and subtract 2 to the power 32, you'll get negative 1. It's not a good idea to take 32nd or 16th power of 2, because this is going to be a very large number. Calculations with those large numbers is not going to be very easy. That's why simplifying it in this way and getting this negative 1 is much more effective.